So the question now is how to drive the relationship between these different scales. I think there is very common relationship that everyone almost know, that the temperature on the Kelvin scale, uh, uh, again I'm still using to use a bracket, but I'm gonna go back to the parentheses here. So the temperature on Kelvin scale simply is 273 plus the temperature uh, on the scale of Celsius, right? If you look to that graph here, let me change that color here. Uh, go for orange color. So if you look to that scale here and that Kelvin scale here, the 0 is corresponding to 273 and the 100 is corresponding to 373 on the Kelvin scale. So it seems to be that all the data is shifted by 100 by 273 degree. That's why this relation is coming from the scale configuration here. So this is the first relationship between the Celsius scale and the Kelvin scale. And the second most known correlation as well between the Celsius scale and the Fahrenheit scale. We know that T in Fahrenheit is equal 32 plus 1.8 the temperature on the Celsius scale. Sometimes we don't write 1.8, we write that as follow at 32 plus 9 over 5 the temperature on the Celsius scale. Either of the forms is correct. Again, you look to that there is always a shift of 32, but the one step on the Celsius scale is compared to 1.8 step on the Fahrenheit scale. The range is 180 divided by 100 steps or 100 pieces. So each piece is 1.8 the value on the Celsius scale, and this is where that 1.8 is coming from, and the original shift at the 0 value is 32, and this is how this correlation was actually driven. Let me call that equation number 2. If you would like to make relationship between the Celsius or the Fahrenheit and Kelvin scale, you just simply combine these two equations together. But it's very uncommon to do that. The last one is actually the Rankine scale, and you will find easily that the temperature on Rankine scale, T Rankine, is simply equal to 460 plus T on the Fahrenheit scale. You compare the Fahrenheit scale here and the Rankine. There is at the 0 value, there is a shift of 460 degree, and this is approximated number. And also the step on that scale is the same as the step on this scale. So that's how this relation is driven. So I would call that equation number 3. So these are the most 3 equations that you're gonna need to convert one temperature value on one scale to the other. If I know the degree C, I can get the Kelvin. I can put the degree C in here. I get the Fahrenheit. I can take the Fahrenheit and put it into this equation. I got that in Rankine. The second important thing to consider here is the relationship for the delta T. You will realize that delta T on the Celsius and Kelvin scale are the same, and delta T on the Fahrenheit and the Rankine scale actually is the Celsius and the Kelvin scale is the same. That's Kelvin here. And the Fahrenheit and the Rankine scale are the same. So the relationship stating that delta T on the Celsius scale is the same as delta T on the Kelvin scale, and delta T on the Fahrenheit scale is the same as delta T on the Rankine scale. And any one of these two, delta T Fahrenheit or delta T Rankine, any one of them is simply 1.8 of delta T on the Celsius scale or delta T on the Kelvin scale. So these are the relationship for the temperature difference between the different scales. So this is give you a relationship between the temperature values, absolute values, and this is give you the relationship between the temperature difference. And you can test that by yourself. Pick any temperature. Let's say that we have T equal 25 degrees C, and the second temperature is 30 degrees C. If you want to get the temperature difference, delta T will be 5 degrees C. If you add 273 for this number and 273 for this number, then you got the difference. 273 will cancel out, and this is why delta T on Celsius is equal delta T on Kelvin, which is going to be 5 Kelvin as well. I hope that explained the temperature scales clearly and how you can actually relate the absolute values or the temperature difference on each one. We will practice more problems on how to use the temperature scales. This is just the basics or the fundamentals of the relationship between the different temperatures scale. By the way, this is the temperature on the Kelvin scale, and on the Rankine scale, it's called the absolute temperature. Keep that in mind. So absolute temperature scale is given for the Kelvin and also given for the Rankine. I will see you guys in the next video.